Hello, I am your Lakshma Reddy sir. We will discuss in this session about kinetic molecular theory of gases. Kinetic molecular theory of gases proposed by Maxwell, Boltzmann and Clausius. What they explain about gases. Okay, so let us see some important postulates of this theory. First point is molecules. I'll just tell you some words and we'll elaborate those words. What they explain is all the gases they contain large number of heavy number of tiny, very small, tiny particles, very small particles. Okay, now discrete particles. They are separated from each other, not joining with any. Okay, so the point is like this: all the gases they contain very huge number, large number of tiny and discrete particles. Tiny, discrete, large number. All gases contain tiny, discrete, large number of particles, which we are calling them as molecules. Second point is about collisions. What is the meaning of collisions? The molecules, they are always moving from one place to another place. The velocities are in the range of 0 to 400 meters per second. 0 to 400 meters per second, very high velocities are there. So when the molecules are moving from one place to another place, if any other molecule is coming on the way, they are going to hit that one. After hitting the molecule, it may come back, it may go in this direction, it may go straight, depends it is. Okay, so not this one, otherwise it can hit the boundaries also. Okay, now whatever the container is there, the container also they can make some, you say, accidents like that. Okay, now so these are we are calling as collisions. So all these molecules they are moving with very high velocities and they are going to hit the container borders, container boundaries, or you can say other molecules. These are called molecular collisions. Okay, so what is the velocity range beta? As I said, 0 to 400 meters per second is the range when they are making and they are going to create some collisions. The collisions are called molecular collisions. The next point is elastic. These molecular collisions we call them as elastic collisions. What is the meaning of elastic? When the collisions are making, whatever the energy the first molecule is having, some energy of this molecule can be transferred to the second one, or the second energy can be transferred to the first one. Energy transfer can happen, but overall energy is going to be constant. Overall energy is going to be constant, that we are saying elastic collisions. So there is no net loss in the energy. That's why we call that is elastic collisions. Okay, but can be transferred from one molecule to another molecule. So elastic collisions. Next point is neutral. All gaseous molecules are electrically neutral, so no attractions and no repulsions are there. Okay, we need some changes later about these kind of some postulates are there in that this postulate is also. So when the gaseous molecules are completely electrically neutral, how can we expect some attractions between them to get that into liquid form? That is all coming topic we'll discuss. Okay, so here according to their postulates, it is gaseous molecules are 100% neutral. That's why no attractions, no repulsions among the gaseous molecules. Then gravity. There is no gravity working on the gaseous molecules. No gravity working on the gaseous molecules. Okay, this is one point. Then pressure. The gaseous molecules pressure, whatever the pressure is there, the pressure is because of the molecular collisions made on the walls of the container. Whenever the gas molecules are hitting the walls, they are going to create some pressure. The pressure is because of the molecular collisions. Then seventh point is volume. About gaseous molecules volume, we are saying gases occupy the complete. For example, if you are taking this classroom, okay, now this room, whatever, if you are taking some perfume smell or perfume or something else, that is going to occupy, the gas particles are going to occupy the complete room. But if you bring all those molecules, they for example, this complete classroom, okay, now that this place is sufficient for them. That means when you compare with the overall classroom, this space is going to be very, very small space. Okay. So when you compare with the overall volume, the original volume occupied by the gas molecules is going to be very, very small. Very small volume is only there. Okay. So the total volume and the original volume of the gas molecule, there is a lot of difference. The original volume of the gas molecules is negligible when you compare with the total volume. Okay, now, but not always. This point also we need some modifications. This point also we make some changes next. And last one is temperature. Temperature is and kinetic energy relation. Average kinetic energy of the gaseous molecules is directly proportional to temperature. Okay, now kinetic energy is depending on the temperature. If you increase the temperature, kinetic energy also increases, because when you increase the temperature, the molecular motion increases, molecular velocities increases, so kinetic energy will be increasing. Of these points, again I am explaining. All gaseous molecules contain large number of discrete and tiny particles. We are calling them as molecules. These molecules move randomly in all directions with high velocities, and they are going to hit, they are going to collide other molecules or walls of the container. We are calling them as molecular collisions. The molecular collisions are perfectly elastic. No energy loss in the molecular collisions is observed. The molecules are perfectly neutral, so no attractions, no repulsions among them, and there is no effect of gravity on molecules or molecular motion. The pressure of the gaseous molecules is due to the molecular collisions made on the walls of the container. The original volume of the gaseous molecules is negligible when you compare with the total volume of the gas. And average kinetic energy is directly proportional to temperature. These are the important postulates of kinetic molecular theory of gases.